At an active commercial estate in the east of England, a portion of the site is being prepared for redevelopment from commercial to residential properties. As part of this process, a due diligence site investigation was carried out by Mott MacDonald. This uncovered chrome-6 and trichloroethylene, or TCE, contamination in the groundwater, thought to be from historic metal plating activities on the site. To unlock planning permission, the site required a strategy that would deal with the on-site contamination, as well as stop off-site plume migration from impacting nearby sensitive receptors. Mott MacDonald worked with Regenesis to come up with a solution that met these needs.
So the site is located on the chalk, which is a principal aquifer in this area. There is some river terrace deposits overlying some of the sites, but not all of it, so in places the chalk is present near surface. The groundwater flow direction is to the north, which takes it away from the sites, which has been a challenge in terms of the risk assessment that we've been looking at. So the site-specific constraints we've had on this site are mainly related to how congested it is and how the commercial areas are ongoing at the moment, so there's people working here all the time. So during ground investigation, during pilot trial and now during remediation, we've had to work around that. Also the site lies on the boundary between two local authorities, so we have a number of regulators who we've been speaking to and working with to move towards a solution, including the Environment Agency. Luckily we've had a very proactive client who is very keen to engage with them and to come to a solution for everybody.
To treat the commingled chrome-6 and TCE contaminant plumes successfully and efficiently, Regenesis suggested a combined product application of S-micro-ZVI and 3D microemulsion so that both chemical and biological pathways could be used to stabilize the chrome-6 and degrade the TCE. A pilot trial was undertaken to verify the aquifer conditions, prove the effectiveness of the treatment, and to ensure that direct push injection was possible down to the required depth of 13 meters below ground level.
One of the key things we wanted to establish was the best methodology to apply the S-micro-ZVI and 3DME into the subsurface. So plan A was to do direct push injection, which you can see going on behind me here. But we also had a provision to install dedicated injection wells. Now the reason for this preference of direct push injection was that there would be an additional cost in installing a series of injection wells along this barrier. Whereas direct push injection is a very simple method, there's no infrastructure left in place, and it lowers the total project cost.
So as part of the pilot trial, we were in regulatory discussions with the Environment Agency and the local planning authorities as part of the planning process. It was a very open discussion with them and we came to a fairly quick agreement on the location and the scope of the pilot trial to be taken forward.
After the pilot trial proved that direct push injection was viable, Mott MacDonald undertook 12 months of groundwater sampling to monitor the effect of the 3DME and S-micro-ZVI on the contaminant concentrations in the groundwater.
So chromium-6 dropped right out very quickly within months post-application. However, it took a while for the conditions in the aquifer to become favourable for reductive dechlorination. We saw in the end good conditions established, but it did take a little bit of time.
This slower start in biological degradation of the TCE was caused by the naturally low nutrient levels in the aquifer. To compensate for this, Regenesis modified the full-scale design, adding more electron donor, some micronutrients, and another product called BDI+, which is an enriched natural microbial consortium containing species of D. halichocoides, a form of bioaugmentation to help kickstart the enhanced dechlorination process.
As well as 3DME and BDI+, we're also co-applying S-micro-ZVI. S-micro-ZVI is a colloidal sulfidated zero-valent ion product that when in the subsurface will distribute widely to not only chemically reduce the TCE all the way through to acetylene, which is a harmless byproduct, but also reduce the chromium-6 down to chromium-3, thereby taking it out of solution, precipitating it out on a stable sulfide and removing the risk to the wider receptors.
The barrier we are completing is 225 metres long, consisting of 75 points at 3 metre spacings. Each point consists of 2,000 litres. We are using a bottom-up approach spanning from 13 metres to 3 metres below ground level. We're using our mobile mixing station on this project. It allows us to co-mix the product with water directly in a trailer into 2 large tanks, which are pumped using a large diaphragm pump directly to our injection locations via hydraulic hose lines.
We started on the western boundary over there, and we're moving up the boundary towards the northern area of the site, where we'll follow the road around the bend and create an L-shaped barrier. So one of the main challenges we've had on the site is below ground services. So being an active industrial and commercial site, it's supplied by various different services, including water, gas, electricity and fuel. So we've had to adapt the shape of the barrier slightly to avoid these services when we're drilling, without compromising the design of the barrier.
The full-scale works were completed over summer, and the first 2 validation rounds have now been completed. Already, hexavalent chromium has reduced by 76% and will continue to decrease. Trichloroethene has been rapidly reduced to below non-detection limits, with minimal creation of degradation products. Now that the parent compound is gone, the residual cis-1,2-dichloroethene will decrease as the treatment and validation program continues. Thanks to the dedication and collaboration of all parties involved, the remediation project is on track to achieve regulatory sign-off on time and on budget. This will allow the redevelopment works to go ahead as planned.